Diversity, lessons from the Barbie movie. Lessons from the Barbie movie. So for this talk, I'm talking. I suppose I could put my email up later on, but that can be passed around. I am hoping that Kirsten Locke, my co-author, will pop in as well. And then we also did the paper from this with Anna Brown, Jonathan Burgess, and Jean Donaldson, and you will see some of Jean's amazing artwork later on in the talk. So I'm going to start by explaining how delighted I am to be here. I was one of the very first postdocs to go through NIMBioS. I think Errol Akshai may have gotten there a month or two before I did, but not that long after. And it was incredible. It was really lovely to do things through the NIMBioS Institute. You can see on the left here a photo set in Market Square during a workshop, one that has a number. Do you have a?
Forgive me, I think we're stuck on your first.
Oh no. Okay.
Is it in sharing mode yet? I'm sorry, I don't mean to interrupt, but
No, please. Let's double check that. So I'm trying to change slides right now. And are they coming through?
Not yet.
Okay. Let me stop sharing and then try again.
Interrupt your rhythm.
No. I can I'll get right back in that, I'm sure. But let's get that right. Okay, can we see this slide here?
Yes. Yeah.
Okay. Next, I'm going to test, and there's going to be a spoiler. You're going to see the next slide. If it will change. Hold on. There we go.
Okay.
Okay.
Yes. All
right.
Thank you.
Awesome. Great. Okay, so here's a slide of me with some distinguished co-authors on Market Square doing a workshop, including a bunch of lovely people who were here, and getting to talk with people in different disciplines was a really big part of my career. You're going to see some of that later on in the talk, but for now, I'll say that it was a contact through NIMBioS that got me my first faculty job in New Zealand, which has changed my life in many exciting ways. On the left, you can see a photo of me with a Kia, the world's only alpine parrot, hanging out on my shoulder, which is just one of the many wonderful experiences I've had as a result of links I made through NIMBioS. So today I'm going to talk about intuitive notions of diversity, evidence from the Barbie movie. I'm going to sort of go through three big points. So the first one is going to be that diversity is important in ecology, and just to review what we think about for diversity. I'm then going to talk about three things that I think us ecologists can learn from the Barbie movie that helps us to better understand diversity. And finally, just in case there's any doubt, I have a section at the end which goes through, sort of the more serious versions of the mathematics that help link the two topics together. So let's get started. Diversity. I'm an ecologist and I'm fascinated by diversity. And I think many of us are both in ecology and people in the broader world. For us, we start a lot by thinking about biological diversity. This, by the way, is the view from sort of a local hike in Otautahi or Christchurch, looking down into the harbor. There's a beautiful hut in the background. But by biological diversity, we think about things like the variety of living plants and animals that are found in a site and the differences as we move from one part of the globe to another. And it's something that seems to be very important in lots of places in ecology, and we'd like to understand why we have the diversity we do and when diversity changes. Even though we all care about this, the overall changes in diversity are often surprise us. And this has happened several times in the last couple of years where we think about biological diversity. We know that diversity should respond to what people are doing. And we go and we get a bunch of data on diversity out in nature, and we take a look, and then it turns out that at the scales that we measure that seem most obvious to us, so like within plots, diversity within those plots does not change nearly as much as we think it would. And this is sort of, to me, I see this as a real disconnect where sort of our expectations about how diversity changes are hard to match up with the patterns that we actually see in nature. And there are lots of reasons why this can be the case, but I'm going to focus on one in the rest of this talk that I think really matters for us as people who think about math and biology and think about math and biology. And that is that what ecologists consider to be an intuitive understanding of diversity might actually not be as intuitive as we think. And so I'm going to refresh this. This is from a teaching issue, but I find this a lot from lots of teaching materials. You can find this in presentations and talks I have with other ecologists. This is a common way that we start thinking about diversity. And so I'm going to read it out here. Diversity is measured by two main components. There's species richness, so that's the number of species that are present, and species evenness, which is how relatively abundant each of the species are in your community. And so those are two things. That's how we talk about this. And, as far as it goes, that seems fine. And of course, this is just the starting point, but, you see why that's a reasonable way to think about diversity. But then you try to formalize this and go through and think about how to analyze these components in the real world. And you get things like this. This is a very influential paper and it's brilliant. And people who are mathematically inclined, I'd highly recommend reading it. So this is partitioning diversity into independent alpha and beta components. Thousands of citations. It's incredible. Look on the left and you've got sort of a section title there. Basic properties of intuitive alpha and beta. So that's two components of diversity. Okay, good. I like intuition. And then you look on the right, and that is an interesting special case of what they consider to be an intuitive formula for diversity. And you can just look at it and you can see that it already looks pretty horrible. And so trying to satisfy those intuitive properties is something that can be difficult to actually do. So if what we consider intuitive is kind of messy and leads to the scary math, is there anything we can do about that? Well, I've been thinking about this for a while, and I would like to propose a radical solution, which is that we talk to other people about it. Ecologists are not the only people who think about biological diversity, and we're not the only people, ecologists are not the only people who think about diversity, and we're certainly not the only people who have intuitions about what diversity is. And so through Te Puna Matatini, which is another awesome interdisciplinary research center, one that's here in New Zealand, I was put in touch with Kirsten Locke, who is a philosopher of education who does work on sort of the experiences of people in underrepresented groups in the education system, which A, was awesome, but B, it led me to realize that the way that they think about diversity in the social sciences and in philosophy is it is a very different starting point from the way that us ecologists think about it.
Well, just to let you know that I'm here. Sorry to interrupt you.
Yeah. No. Would you like me to say more nice things about you?
No. I just wanted you to know. Kia ora, everybody. I know that Will didn't know that I was here, so I thought that I would just let him know.
All right.
I'm laughing in the background at this photo.
Yes. All right. So I'm now going to, so one way to realize this is to go through sort of like the academic literature on underrepresented groups. But a lot of the big points that we're making are made very, very well in the 2023 Barbie movie. And I'm just going to go through some of the highlights here about them. So just a reminder, so the Barbie movie, it's a satire about diversity. You can even find I have at the bottom a link of sort of like an article talking about sort of diversity of underrepresented groups and what's set up in the movie. It has box office revenue of 1.4 billion. They didn't get that by being unintuitive. And, I can talk about the papers in ecological theory that this has had more impact than that. And a lot of the themes that come up from that movie are based on ideas in the social sciences. Okay, so to highlight those ideas, I've got this screen sharing thing. I can't read the title off right now, but that's fine. To make the analogy clear between the two movies, I'm going to set up a little bit of terminology and then work through some of the points that come up with this. So in ecology, it's useful to think about what we're doing is focusing on the diversity in a ecological community. So on the left, I've got a community of flowers. You can see there are purple ones and there are red ones. For now, this is a math biology talk, so we're not going to say any more than just they're red and purple, but there are two species that are there. And the focus is on the species level contributions of diversity. In the Barbie movie, the interest is in diversity, but it's not diversity in a community. Typically, the big thing that they're interested in is the diversity of characters who have status in society. So it's who are the characters who get to make decisions and who are the ones who don't get to make decisions and who are the ones who are valued and are not. Kirsten may have a clearer way to say that, but I have that as my bullet point here. The focus is on individuals, not species. And so let's even make the terminology a bit more precise. So in a ecological community, there are individuals in different categories. So the purple species, the red species. In the Barbie movie, there are different types of characters: Barbies, Kens, Allens. And even though there are the different types, the storytelling focuses on what happens to the individuals, not to the types as a whole. And so let's just see how that plays out. So the first place that you can see this is, instead of thinking about the richness of characters, so how many different characters there are, everything centers on what happens to an individual. So here, for example, I have a slightly blurry screen cap of the movie. This is a scene where Ken has been trying to interact with Barbie, and he is then told, "Oh, I don't want you around. This is girls' night. Every night is girls' night. You have to go now." And the importance of the story is told by focusing on what happens specifically to Ryan Gosling's character. And you can even see this in the screen layout. I'm not sure if my arrow will work over here. If you can, there's Ryan Gosling by himself, excluded. And then the community of people with status are inside Barbie's dream world, hanging out together. Okay. And again, this is conveying the same notion as richness, but just focusing on the individual level, not at the group level. Okay. Now that we've got richness, we can think about evenness. So the way this is presented, and I quoted this earlier in the talk, is we have an ecological community. There are two species in here. So the richness is about two. But if you look really closely, you'll see that the purple species is more common than the red species, and so that means that the diversity is a little bit lower than you'd expect. And when this is presented, we often have formulas that look a little bit cryptic. So I've got here an example of the Gini-Simpson's diversity index, which is one of the ways that students are taught to do this. And we say, oh, well, you use this formula, and when evenness goes down, diversity goes down, which is true of the formula. So that's fine. The Barbie movie also talks about evenness, but it does it in a way that is far more intuitive. There's a beautiful scene on the beach. And on this beach, they actually act out the mathematical equivalent of the Gini-Simpson's diversity index, which is that that index summarizes interactions between pairs of individuals. The whole scene is about 1 minute long. I wasn't told I had enough time, so I'm not going to go through the whole thing. But there is a minute of, "Hi Barbie, hi Ken. Hi Barbie, hi Ken. Hi Barbie, hi Barbie." And everywhere that you're going, you're looking at which individuals are interacting with which other ones in the community. And so that's acting out what diversity is doing. And then at the very end of the movie, at the very end of the scene, we get, "Oh, hi Alan." And we were introduced to Michael Cera's character, Alan. There are no multiples of Alan. He's just Alan. So we have two species that are equally common, more or less, Barbies and Kens. And then we get Alan, which is present in the community, but is very, very lonely and awkward. And so that's the individual level focus. That's the individual level equivalent of thinking about species evenness. And it's done much more intuitively than the way that us ecologists normally present it. Okay. I'm now going to get to one more example from this, which is that ecologists, when we think about diversity, we're often interested in diversity across spatial scales. So it isn't just a matter about thinking about how many species are present in one community. We're interested in how that diversity is distributed as we move from one community to another across our landscape. And when we do this, there's a bunch of lingo and terminology. This is a very quick talk, so I'm just going to give the version that's here, which is beta diversity summarizes dissimilarity among species found in communities. So you look here, I have the two orange circles. Each one represents a separate community. And there's not just diversity within a community, but there's also dissimilarity among communities. Okay. The way that we present this as ecologists is usually by thinking about a comparison of overall diversity versus the diversity within each local community. This is this horrible ratio formula I have here. And that's one way to think about it, but I'm not going to go through it in entire details because the Barbie movie has a much more intuitive way to describe it, which is that the entire plot of this movie is a comparison as you move from one community to another across a landscape. So in the movie, you start in Barbie Land. And then you get from Barbie Land and move from Barbie Land to the real world. And the entire point of the movie is thinking about how the status of individual characters changes from one landscape where from one landscape to another. And you'll notice before I had the picture of Mount Rushmore in the Barbie movie, which is a pointed critique where it's all Barbies that are in charge. And here I have watched many clips of the Barbie movie over the last little bit, and you can see the Mount Rushmore version in the real world, which also has, pointedly shows which characters are included with high status in the states and which are not. All right. So I'm now going to put in a slide from one of my papers, which is sort of going through the full math version of this and just describe this idea. So you can go through and think about our measures of diversity, like beta diversity, not in terms of the differences in communities or the differences in species, but in terms of what happens to each individual along the way. So what this figure is doing is taking one measure of diversity, Shannon entropy, and breaking it down into what happens to each individual in the local community versus the regional community, and thinking about beta diversity from this individual point of view. And I mean, I had to go through a lot of work to get this figure to the point it was. But a key thing that happens in the Barbie movie succinctly describes exactly the same phenomena. This is from the Oscars last night. I'm just a Ken. Anywhere else, I'd be a 10. And the key point that's being made is that when you focus on the individual status of Ken, he's included in the patriarchy in the real world, and then excluded from status at the start of the movie when he's in Barbie Land. And if we had more time, we could play through the whole clip of this from the Oscars, which I think is remarkable. But I may just leave that as a homework assignment to the students afterwards. And I'm just going to summarize these points here. So ecologists focus on diversity of types or species. The Barbie movie highlights why individual contributions can be a more intuitive way to think about the measures of diversity that we have. I've tried to highlight the individual level contributions as an alternative to richness, to evenness, and to spatial variation. And I've tried to highlight how the math between the two can be linked. And I've now talked for 20 minutes. I could go, I can leave time for questions right now, or if you'd like, I can put a little bit more math in as we go.
I say go for it, but if it's okay, just a few more minutes, because I do want to leave time for people to ask you questions, and people might have to drop off
Absolutely.
the half-hour mark.
Yeah. Okay, that's good. I'm really glad I get to show the next slide. This is from our amazing collaborator and design expert, Jean Donaldson. So what are the implications of doing this? So this is something that is in the literature, but I don't think it's been highlighted clearly enough. The notation we use to quantify diversity can be adjusted so that you play up the species level contributions or the individual level contributions. And so I quoted the Joss 2007 paper before, which again is amazing. I really like it. The notation there is set up so that you take your measures of diversity and you convert them into equivalent units of species richness. So you see here, you have this measure, and on the bottom, what I've got is diversity in terms of richness. So you can have a community where you have a diversity of 1.5. If you have a community where you have two species and one is slightly more common than the other. And, some ecologists think this is always the most intuitive way to measure diversity. It may not be. And there's a lovely paper that came out a year or two ago, sort of updating measures of species diversity. And they point out that you can also take the same formula and expand it out so that you have a measure of individual rarity. So how lonely is each individual in the community? And then take an average of that across all individuals in your community. And functionally, it's the same formula, but the notation on the right is then easier to highlights the individual level contributions rather than the group level contributions. To highlight again sort of the equivalence between these two ways of doing things, in the paper I took the characters that are actually where the actor or actress is named in the movie, and compiled a small data set and calculated Jeannie Simpson's diversity. On the left, I've got a calculation that does it using the standard package in R. On the right, I've got the calculation using the individual level way to write out that formula. And if there's any doubt, you can write them out, and they're both exactly the same. And I'll put up just one more so what thing, which is that ecologists have been trying to link the mechanisms that measure that affect species diversity to the to sort of the measurements of diversity. So you have like your measurements of how much diversity you have, and then you have mechanisms. A lot of the mechanisms that have interested ecologists are things that act on individuals. So you look on the right, this is from a science paper that came out a couple of years ago. You have things like dispersal and physiology. Those are things that act on individuals. And if we can't spot how individual level processes are scaling up to the measurements, then it's going to be really hard to predict changes in diversity. And I have another graph of one of my papers that does this. And that's most of what I wanted to say. I'll just add one more final reminder of this, of what I've tried to highlight in this talk is it's nice to talk to other types of researchers. And I have here a screen cap from the way I got in touch with Kirsten is through Te Puna Hamatatini, the Institute. And they'd been running a project thinking about the success, especially of Maori and Pacifica students in New Zealand, including Kirsten's lovely student, Tony, who's a high school teacher part of the time, and talked about his experiences with that, along with doing academic research. And just that's been a big part of getting this project on the road. And it's been like just a lovely reminder of the added how nice it is to talk to other types of researchers. So I think that's it. That's what I'll say. Thank you very much.
Thank you so much. I am positive I'm speaking for everybody when I say that was fantastic. Thank you. So now the lovely part about our Morsels series is that it's not just the brilliant thoughts being shared, but also the community and the opportunity to talk to each other. So if anyone has either comments or questions, please just unmute and go for it. And also respect anyone who needs to drop off we absolutely understand, zero pressure.